Hey, this is Michael D'Agostino, and we're going to be going over choosing between SN1, SN2, E1, and E2 reactions. The first thing we're going to be looking at is choosing between SN1 and SN2 reactions. And there are three factors we're going to be looking at in order of priority. The first factor is the substrate. This is often the most important and most decisive factor. So if a compound is methyl or primary, then it is going to proceed an SN2 reaction. If the compound is a tertiary carbon, then it's an SN1 carbon. That's all you have to look at to determine SN1 or SN2 reaction. But what happens when it's a secondary substrate? Well, they can proceed in both SN2 and SN1, so we need to consider other factors. And that leads us to our second order of priority, which is looking at the nucleophile. Here we have a secondary substrate. We're going to apply a strong nucleophile to it, and this results in inversion of the chiral center. This is because strong nucleophiles result in an SN2 reaction. Next, we're going to apply water to our substrate. This results in a racemization of the compound because weak nucleophiles result in an SN1 reaction. Now, there's also a third order of priority that we're going to be looking at, which is the solvent. Polaric aprotic solvents favor an SN2 reaction, and polar protic solvents favor SN1. Here's an example where our DMSO results in an SN2 reaction. And as you can see, polar aprotic solvents usually result in a faster rate than polar protic solvents. Next, we're going to be looking at choosing between E1 and E2 reactions. So choosing between E1 and E2 is easier because the reactivity pattern is the same for both. The rate of E1 and E2 increase with the degree of substitution. So our two compounds that we're going to be looking at right now are a primary substrate and a methyl group. So primary substrates can only do E2 reactions. Why is this? Because they have no carbon cation for elimination reactions. Similarly, methyl groups can't do elimination because they can't form carbocations. So we can look at the strength of the base to determine if a secondary or tertiary carbocation will be E1 or E2 favored. So E2 reactions are favored by strong bases, and E1 reactions are favored by weak bases. So here we have a compound. We're going to apply potassium tert butoxide in a solvent of DMSO to it, and we'll get an E2 reaction out of it. Note that we also have a polaric aprotic solvent here, which tends to favor an E2 reaction. On the other hand, we can apply water to our compound. Water is acting as both the base and the solvent, and we'll end up with an E1 reaction. And note that water as a polar protic solvent favors an E1 reaction. So remember that strong bases result in E2 and weak bases result in E1. Now we're going to ask the question if we need to choose between SN1, E1, SN2, or E2 reactions. And we're going to go through a little flowchart to describe this. So we start with our nucleophile. The first thing we're going to be looking at is whether this nucleophile is strong or weak. A strong nucleophile will prefer a bimolecular reaction, while a weak one will prefer unimolecular. Weak nucleophiles tend to be water and alcohols, but you might see a few other ones. So strong bimolecular nucleophiles will favor SN2 or E2 reactions, while weak unimolecular nucleophiles will favor SN1 or E1 reactions. This shows that whenever we have this problem of deciding between the four of these types of reactions, there's really only competition between SN1 and E1 and SN2 and E2. So when we have a weak unimolecular nucleophile, we'll obtain both an SN1 and an E1 mixture. But we can change that by either adding or taking away heat. Because heat favors elimination, when we add heat, we'll favor the E1 mechanism. Similarly, when we take away heat, we'll favor the SN1 mechanism. Now, what if our nucleophile is strong and bimolecular? Well, we need to go a step further, and we need to decide whether this nucleophile is bulky or non-bulky. If we have a bulky and strong nucleophile, we'll end up with an E2 only product. If we have a non-bulky and strong nucleophile, then again, we're going to have to go a step further. We need to decide if this nucleophile is going to be non-basic or basic. If we have a strong, non-bulky, and non-basic nucleophile, we'll only get SN2 as a product. On the other hand, if we have a strong, non-bulky, and basic nucleophile, this can do both SN2 and E2. So we need to look at one more factor to decide if it's going to go to SN2 or E2. So we'll look at the compound. If it's a first order carbon cation, we'll favor an SN2 reaction. If it's a second or third order carbocation, we'll favor the E2 reaction. So this is only one good way to decide which reaction a nucleophile will favor. And with this, I hope it helps.